In this video, I will talk about sampling distribution for proportion. Pi is equal to the proportion of the population having some characteristic. The sample proportion, denoted by the letter P, provides an estimate of pi. P is calculated as x over n. X is the number of items in the sample having the characteristic of interest. N is the sample size. Your proportion is always between 0 and 1. And is approximately distributed as a normal distribution when n is large. So, a sampling distribution of p is approximated by a normal distribution if n times pi is greater than or equal to 5 and n times 1 minus pi is greater than or equal to 5. So the sampling distribution will be the mean is equal to pi, or your population proportion, and the standard deviation is the square root of pi times 1 minus pi all over n. So let's look at an example. If the true proportion of voters who support Proposition A is pi equal to 0.4, what is the probability that a sample of size 200 yields a sample proportion between 0.4 and 0.45? So they told us our pi, which is 0.4, and they told us the sample size n is 200. We want to calculate the probability that the proportion is in between 0.4 and 0.45. So, if you wish to use the z-table, you can. You will have to standardize your p to a z-value. And this is how you standardize it. So it will be p minus pi all over your standard deviation, which is the square root of pi times 1 minus pi all over n. Okay. So I am not going to use tables, but I'm going to show you how to standardize if you wish to use the tables. So we have to calculate what our standard deviation is for P, for our proportion. So when we plug everything back in, we get our standard deviation is 0.03464. You already know that the mean of the proportion is whatever the pi is. So our pi is 0.4. So we have this and we have this. And then you can go ahead and standardize, convert it to z-scores, and then use your table. And once you do that, you're going to get an answer of 0.4251. Okay? I'm going to show you how to use technology, and we've done this before because this is a normal distribution. So we already got our numbers that we just need to plug in. We got our mean and we got our standard deviation, and we know what p we're looking for. We want between 0.4 and 0.45. So let's go ahead and use StatCrunch. Oops, sorry. I'm going to go to calculators, normal, and we know our mean is 0.4 and our standard deviation is 0.03464, and we want between, so let me go ahead and click between, with 0.4 to 0.45. Hit compute and we get 0.4255. Okay, so this number is a little different from the answer that we got when we did it by hand. As you can see, it's 0.4251. The thing is, I think it has to do with rounding error. So it's just this last number that's kind of off. But when you do it with technology, you got a 5. When you do it with the tables, you get a 1. Okay, so it has to do with rounding. I can guarantee you it's the rounding error. Okay, so what does this mean? The probability is 42.55% that between 40% to 45% of the 200 voters will support Proposition A. Okay. Let's do another problem. You plan to conduct a marketing experiment in which students are to taste one of 2 different brands of soft drinks. Their task is to correctly identify the brand tasted. You select a random sample of 200 students and assume that the students have no ability to distinguish between the two brands. What is the probability that the sample percentage of correct identifications is greater than 65%? So you're only looking at two brands of soft drinks. So you have a 50-50 chance of picking the correct one. So our pi is going to be 0.5. We looked at 200 students. I put 300. So this should be 200. And we want to know the probability that the proportion is greater than or equal to 0.65. How many, we want to see whether or not, what's the percentage of correct identifications will be greater than 65%. So that's 0.65. Okay. So we're looking at this area here, this little small area here. So we know that the mean is 0.5. We need to figure out our standard deviation, which will be 0.5 times 1 minus 0.5 divided by 200, and we're going to take the square root of that. We get 0.0354. So these are the two values that we need to plug into StatCrunch. So let's go to StatCrunch. We have a mean of 0.5. Standard deviation is 0.0354. We want the standard, so we want everything greater than 0.65. Okay? When I hit compute, I get this really small number. So it's pretty much 0%. So if we go back here, this is really small. Your probability is pretty much 0. So what does this mean? The probability is 0% that 65% or more of the 200 students will correctly identify the brand tasted. You can also do these calculations in my Excel template. If we go back to the first problem, we know that the mean is 0.4 and the standard deviation is this. And we're looking in between 0.4 and 0.45. So if we go back, mean is 0.4, standard deviation is 0.03464. Oops, 464. And we're looking at a lower and upper bound. So the lower bound is 0.4 and the upper bound is 0.45. And we want this number here, and as you can see, I get 0.4255, and that's what we calculated before. Okay. So this is just the normal distribution that you've worked with before in the previous chapter, or when we did it before with normal distribution. You can also do the next problem, which is this one with the soft drinks. We're just going to plug these numbers into the template. We got 0.5 as the mean, and 0.0354 is the standard deviation. We do not have a lower or upper bound, so we're going to have an x value, and we want it to be 0.65. We also want the greater than or equal to, so we want this number here, right here that I highlighted. And as you can see, it's also a small number. Remember, when you see E negative and a number after that, in this case we have to move our decimal place 5 places to the left. So when we do that, that number is pretty much 0. Okay, that's the end of this lecture.